As Julie's got enough to say, I'm Josh. I'm one of the thinking skills teachers for Kikito. And what I want to do today is we're going to do a brief introduction effectively to the art of thinking skills. So what is thinking skills? Why should we bother learning thinking skills? And some basic approaches and ways to think about tackling some of the problems that we see inside the thinking skills sections of the test. So without further ado, we'll begin. The first thing I want to do is just give everyone a brief introduction to what this talk is going to be about. There's a few different sections to the talk, and they're about 15 minutes each. So to give you an overview, we'll start with a brief introduction to what is thinking skills and some of the different question types that you will probably see. After that, we'll move into some common mistakes that, in my experience, I've seen students make quite a lot. So that'll be the next 15 minutes. The third 15 minutes, we'll look at some common learning difficulties. So these are things that students commonly report as having issues with, perhaps areas of difficult questions, things like that. And finally, in the last 15 minutes, we'll go through some basic tips and strategies. In that sense, I wanted to talk about how can we improve, what's the best way to go forward from here on now in terms of getting better at thinking skills. And finally, in the last approximately half an hour, there's some questions I'll answer so we can open that up to the meeting and go through some of those. So let's get started. The first thing I want to address is why even bother? Why do we care about thinking skills? Now, the obvious answer, and perhaps the answer that a lot of you were expecting, is that it's in the new selective schools test. And the selective schools test, of course, was changed very recently. And what I've done is I've just taken a small graphic here from the Department of Education's website. And here you can see some of the different elements of the test. We still have reading, we still have writing. Maths has been changed to mathematical reasoning. But what we should see, of course, highlighted here is thinking skills. And given that the test is only 4 sections, we can see that clearly the Department of Education thinks that thinking skills is effectively of the same importance as mathematics. You know, it's one of the 4 major sections of the test. We have 40 questions in it, 40 minutes, relatively, not too time pressured, but still relatively fast paced. So definitely something important for any student who's considering taking the selective schools test, which I imagine is a lot of the students in the Zoom meeting today. However, I didn't want to just leave it at being something that we do for a test. I think that personally, I quite like the introduction of thinking skills into selective school curriculum, because I think that a lot of the skills I've seen and all of the problems that I've seen are really quite useful. So critical thinking in especially prepares well for any humanities subject. As we'll see as we go through this presentation, it involves a lot of the logical reasoning, the comprehension, logical breakdown skills that you'll need to use in many different types of humanities subjects. And by humanities subjects, I mean anything from history to economics, even geography, legal studies, and obviously English. So across the wide spectrum of humanities skills, what you'll learn in thinking skills can be applied to those subjects. Problem solving, which is sort of the other half of thinking skills, is also useful. So it's useful in mathematics quite evidently, because lots of maths is simply based around being faced with a problem and figuring out how to solve that problem. But it's a good foundation for effectively any subject, even past the high school level. So why bother with thinking skills? The answer, I think, is twofold. Firstly, I understand that obviously the selective schools test is a big concern for many parents, many students, and we want to do well. That's very, very understandable. And learning thinking skills is very important to achieving that goal. But secondly, I want students to approach thinking skills not just with the aim of performing well, although obviously that should be a goal, but also the aim of developing some skills that they can actually use. So I want students to come away from the thinking skills class thinking, I understand a little bit better how to break down an argument. I understand a little bit better about how to rationalize a problem and understand the problem, not just go, I understand better how to cheat, or not cheat, sorry, but how to game the test or game the exam. So that's the sort of attitude I'd like to approach the thinking skills. So a brief introduction to some of the different questions we will see in thinking skills. The first type is the logical thinking questions as described on the Selective Schools website. This is very similar to some of the GA questions you would have seen in the past. So if you had done any of the papers before the last few years, you would have seen these kinds of questions. And these are questions that have a focus on quote unquote problem solving. You're given some sort of pattern, you're given some sort of diagram, you're given some sort of verbal description of a problem, and you're asked to figure out a solution. It could be mathematical, it could be visual, it could be spatial, it could be some sort of riddle or puzzle, it could be anything. But the focus is, here's a problem, how do we solve it? So I'll let everyone have a quick read of question 40 here. So just on the left, starting with 4 trees. So take a quick read, and then we'll discuss what makes this a logical thinking problem. Now, we won't do this problem. We'll go through a few problems a little bit later in the talk, but I think this is a good description of some of the different challenges you'll be faced with inside logical thinking. You'll be given a visual diagram, and firstly, you'll need to understand, what does this diagram even mean? What is field X? What is field Y? What does it mean by taking a photo of these trees? So that's the first challenge. How do I turn this visual diagram into something that makes sense, something I can engage with and actually solve? And then we can look at some of the different skills that will be required. So firstly, we'll need to be able to identify the different, looking at the different visual or spatial combinations we can make. So this question effectively asks you to consider, how many different orders can we view these 4 trees depending on our location in field Y? And the key part in realizing this question is realizing that we can divide this diagram along the axes of each tree. So axis 1 here, you can see, I actually annotate just to make it a little bit clearer. Axis 1, axis 2, axis 3, and axis 4. And from this, trying to determine what combinations. And then the second skill that we'll need to use is knowing how combinations work. Say, given that we have 4 trees, what are the different varieties in which you can arrange them, and being very concrete and being very definite in knowing just exactly how many. So there's a little bit of mathematics in there, there's a little bit of spatial reasoning in there. We get a whole bunch of different skills all applied in solving a problem. So however, we've seen all this before. This is not entirely the same as general ability, but it's got quite a lot of similarities. What's different and what's almost entirely new is this critical thinking portion of thinking skills. And this is very different from your typical general ability question. And the focus on this is not on a problem. It's not as if there's a diagram or some sort of mathematical dilemma that's being posed before you. The focus is on an argument. So this would be some sort of policy, some sort of opinion, some sort of idea or belief that the author wants to discuss. And what these questions ask you to do is effectively understand what is being said, but more than that, understand why the author has used these words, why the author has put in this particular sentence, understand how does the author attempt to persuade you to their opinion, and basically understanding how words can be used to change someone's mind to affect a logical argument. And once we understand, of course, the next stage to it is being able to apply our own reasoning and assessing which of the answers is the best fit. And for students who haven't had a lot of experience with these kinds of questions before, it's often a bit of a sticking point here. So we'll discuss it in a little bit more detail later. But what I wanted to do just, at first is introduce the 2 broad kinds of questions you'll see: the problem-solving focused logical thinking and the argument-focused critical thinking. So moving on to a bit of a deeper look at logical thinking, as I mentioned, there's a whole variety of skills that we may see applied to logical thinking. So just if you could leave questions until the very end, we will definitely come back to those. So in terms of logical thinking, there's a whole bunch of different skills we can see. So mathematical problem solving is obviously one of them, but some of the other ones we see are things like spatial awareness and riddles or logical reasoning. Perhaps we should take a look at question 7, because I think it's a good demonstration of what these problems actually ask us to do. So I'll give it a quick read. So Callum and his friends cycle from A to C, passing through B. During the trip, he asks his friend how far they have cycled. His friend replies, 1/3 as far as it is from here to B. 10 miles later, Callum asks him how far they still have to cycle to reach C. His friend replies again, 1/3 as far as it is from here to B. How far from A will Callum have cycled when he reaches C. I found this question very interesting because in my experience with my students, the mathematics is very simple. And I would say that over 90% of my class is able to do the maths. However, this was quite a sticking point for a lot of students, not because the maths was hard. I think a lot of my students were quite gifted at maths, but because they couldn't understand what the question was asking. So problem solving is not just, can you solve this equation? Can you do this algebra? Or can you calculate these ratios? It's how do we apply these mathematical skills to perhaps not a real life problem. I'm not sure anyone would actually have these kinds of conversations with each other, but to a theoretical problem. So let's take a look at what it's saying. Effectively, what it's asking us to do is identify 2 points on this line. Again, we have a visual diagram that we need to understand and figure out the distances between them. Now, I'll save the trouble of having to work it out yourself and just tell you that the distances can be approximated to something like x, 3x, 3y, and y, based off the information that we have been given. So we've turned some logical information into a mathematical solution. And just to give you the brief answer, how we solve this is something like 3x plus 3y equals 10. This is the distance here. And then we can convert this to a total distance, which creates 4x plus 4y. And this is the maths part, right? I asked students from here, how can we solve the question? And most of my students can do it. How to get from 3x plus 3y to 4x plus 4y? The answer is very simple. We divide by 3 and we multiply by 4, which gives us an answer of 40 on 3. But with how simple the mathematics is, many students could not even reach this point in the first place, because what the question is asking us to do is not just, can you do ratios? Can you understand what x and y are? It's asking us, can you turn this problem? Can you understand what's going on? So we're clear that's here. Some of the other questions we see, things like visual reasoning. So this is about pattern recognition. Can we see what the pattern is? So we have this sort of upside down house, house, upside down house. We have this alternating diamond shape, circle shape, diamond shape, and ask you to recognize the pattern and apply that pattern multiple times. And from that, discover which of these is the missing tile. So that's one of your more classical spatial reasoning questions. And finally, this is also somewhat new. We have these sorts of logical reasoning or riddles, where you're given, again, a lot of verbal information, and it's your job to figure out through a step-by-step process, what order is sitting around the table, or what order people are sitting along the line, or who lives in what house. There's a lot of different variations, and it's very difficult to cover all of them. But this is just to give you an idea of some of the problems that exist inside logical thinking. So that's logical thinking. Remember, this is our problem-solving focused questions. We'll move on now to the critical thinking questions. This is the new stuff. So again, what I want you to take away from this is the argument-focused questions. We've started with the problem-solving focused questions. Now we've moved on to the argument-focused questions. And we see that they're all trying to tell us something. They're all trying to convince us of something. We can take a look at question 24. So trophies are kind of prize given out for winning some kind of event or competition. They're usually a physical item, often shaped like a cup or shield, which is presented to successful participants. They can also serve as a physical record of past winners, which could be inscribed on the trophy itself. Now, there's no problem here. The question doesn't ask you to find anything, doesn't ask you to solve for X. What it does is it tells us some information. It asks us, do you understand the information? Do you understand what's being said? And to test your understanding, it asks us, can you evaluate, can you make a judgment on the value of these two people's opinions, Thomas and Felicia? Now, there's a lot of different kinds of questions that can be asked. For example, strengthen and weaken arguments are very common ones. If you see down here, so which one of the following is strengthens the above argument, which one of the following weakens the above argument. Other kinds of questions you might see ask the student to identify a flaw in the argument. Maybe they could ask the student to identify the principle or the assumption in an argument. Perhaps they could even ask the student to figure out which statement is true or false based on the argument. Regardless of the specific variation, the key thing for students to remember is that it's always based on the argument. So step one, always, regardless of what the actual question is to see, do I understand what is being said? And do I understand the techniques, the strategies, and the evidence that the author has used to prove their point? So regardless of the actual wording of the question, the focus is the same. What is the argument being made? How is the argument made? Why has the author chosen to make the argument in that way? So that's the critical thinking side of things. So now that we've covered sort of the brief kinds of questions, I thought I might go over some very common errors. Now, I'm not going to go through anything too complicated because I think it's actually more useful if we go through the basic errors, the errors I see coming up again and again, and the errors that are very easy to correct. So the first one, misreading, happens all the time and always pains me a little inside when I see a student make a mistake from misreading. And the conversation goes a little bit like this. I usually have one every lesson where the student will give me a fantastic explanation. Everything makes sense. The logic is perfect. And at the very end, they'll say, this is why C is correct. It most weakens the argument. And I'll have to remind them, sorry, the question says what strengthens the argument the most. And then they'll say, oh, I thought it said weakens. Unfortunately not. So one of the very common errors that we see is simply misreading the argument. Now, I put in question 21 because I wanted to reinforce the point that misreading is not isolated to English style questions. If you look at 21, I'll quickly read it out for everyone. In Miss Perrin's class, 75% of the students are boys. There are 18 boys in the class. What is the total number of students in Miss Perrin's class? A very simple mathematical question. All that it asks the student to do is realize that if 75% is 18 boys, then 100% of the class would be 18 divided by 3 times 4. Because to convert 75 to 100, we divide by 3 times 4. We do the same with 18. We divide by 3, 6. We times 4. Our answer is 24. The maths is incredibly simple. There's nothing to it. Most students could do it, but where do mistakes come in? Well, firstly, perhaps students misread the total number of students for the total number of girls, because perhaps in the past they've seen a question which says, if there's a number of boys in the percentage, then what's the difference between that and the total class? They think 24 minus 18 is 6, therefore the answer must be A. Unfortunately not. An even more basic kind of mistake is, and a lot of students, even very gifted students do this, is that they do the entire question in their head. They think the answer is 24, but between realizing the answer is 24 and writing down the answer, the 2 has become a 1 and they circle B 14. So even the most talented students can fall for these tricks because they don't take the time, they don't take the effort to make sure they don't make these very common errors. Some very gifted students simply have the ability to think too fast. And this is sometimes what happens. So what are some of the strategies that we can use to avoid this? Well, I think first of all, taking your time. Reading the question shouldn't be the most time-consuming part of your test, but it's the easiest way to move marks. So take your time when reading. Second thing, we can highlight keywords. So especially things like strengthen versus weaken, put a double underline. If they allow you a red pen, put it in red. Make sure we don't easily confuse words like that. However, this is all very simple misreading. Misreading can also be a little bit more complex. One of the examples from my class a few days ago was one student, I believe, misread a statement because they missed the first few words. The first few words were, it is a bogus assumption that X is true. And instead of reading that, they just said X is true. So they came, in fact, to the exact opposite conclusion of what is going on. Clearly, they skimmed the passage. They didn't spend enough time looking at what exactly it said, or perhaps they didn't know what the word bogus meant. There are a lot of reasons why misreading occurs, but it doesn't change the outcome that a mistake has been made. So misreading, very common. Some of the strategies we can use is taking your time reading the question, highlighting keywords, all things that I think most students have come across before, but I just wanted to highlight again because they are important to note. What we'll look at next is first impressions. This is where students tell me, I'll ask students, why did you pick B? Or why did you pick C as your answer? And they'll just tell me, it felt right. Unfortunately, it felt right is not really a justification. So to give you an understanding of why this would occur, let's take a look at question 8 here. So question 8 reads, coastal ecosystems are a diverse and beautiful environment. However, they are threatened by erosion. Sand is continuously washed away by waves and wind, which dissolves the shape of the beach and destroys the habitat of the animals that live there. These animals are specifically adapted to this area, so they cannot simply be relocated to other environments. The public needs to put more effort into saving these amazing coastal beaches. So what is this argument trying to tell us? It starts us off with a description of how great our coastal beaches and our coastal environments are. Then it tells us the problem. It says, there's a lot of damage going on. Sand's being eroded, the animals are hurting, the animals are losing their homes. If we want to fix this, then the public needs to put more work to save our amazing beaches. Now, two answers that I see come up very commonly are B and C. And sometimes the reasons that are given to us can be very simple. So one student once told me for this question, they picked answer B because coastal ecosystems was the first two words. And they thought, therefore, because the argument was talking about coastal ecosystems and answer B was talking about coastal systems, it sounded like that would be the correct answer. Now, that might be fast. That's a very fast way to do a question. Unfortunately, it's not a correct way to do a question. So you cannot simply match words, which is what I'm getting at. A lot of students simply try and recognize patterns and recognize phrases that are duplicated between the question and the answer, and therefore they assume that's correct. But unfortunately, in critical thinking, we need to go past just recognizing patterns. We need to make sure we understand what exactly it is we're being said. Similarly for answer C, they simply recognize the words erosion. They see here that erosion is causing the damage, and they think, oh, that means if this is talking about erosion, the question talks about why beaches are being destroyed by erosion, that must strengthen the argument. However, of course, that shows they haven't really understood what's being said. They haven't understood that 8 talks about the human impact of erosion, whereas C addresses how erosion is driven by natural forces. Clearly two very different concepts. So what I want you to take away, students and parents alike, is in these critical thinking skills questions, it's not enough to simply find common words or find common phrases. We must ensure we actually understand what is being said. How can we do that? I think the best way to do it, in my opinion, is to have a robust method of checking yourself, stopping yourself jumping to these assumptions. And to do that, I would encourage students, before they even attempt to put down an answer, to justify in their own minds, this is what I think the argument means. So read the passage twice if you need to, and then tell yourself, okay, I think this passage means this. This forces you to test, at the very least test, if you have some sort of basic understanding of the passage, rather than going, oh, coastal ecosystems, erosion, that makes sense. So the answer for this one is A. Now, human pollution and construction are never mentioned in the argument, but if we follow the reasoning, it makes sense. 8 talks about why the public, why humans need to do more to stop erosion. A talks about why pollution and erosion made by humans speed up the destruction of beaches. So clearly, if that is true, that would mean that humans need to do more to fix the problem they have started. So first impressions, it just felt right. We need to move past simply matching phrases and moving on to making sure we actually have understanding of what's being said. The third problem that I see quite often is we get almost to the ends, we almost get the correct answer, and then we forget the final step. And sometimes I have to remind my students, what about this? And then all of a sudden, a light bulb goes off in their head and go, ah, I knew it. So how can we try and how can we try and stop this missing the final step from happening? Well, let's take a look at question 36, which I think is a very good example of missing the final step. It states, in a doctor's waiting room, there are 6 seats in a row. Mr. Spencer arrives with his 2 children. He wants to sit between his 2 children. 3 other people arrive who do not mind where they sit. How many different possible seating arrangements are there of the 6 people? Now, some students don't like this kind of question. That's understandable, but a lot of students are quite good with these. And they very quickly come to the realization that Mr. Spencer and the 2 children can effectively be treated as a single unit. Because the children and Mr. Spencer have to sit together, then we can basically treat them as one big block of 3 people. So how many ways can we arrange a big block of 3 people? A lot of students came to the correct conclusion. We can arrange them in 1, 2, 3 over here. We can arrange them in 2, 3, 4 over here. We can arrange them in 3, 4, 5, or in 4, 5, 6. Or in other words, there are 4 different ways to arrange Mr. Spencer and his 2 kids. Now, the question, of course, is how can we arrange 3 people in the 3 remaining seats? Well, for the first person, first person has 3 seats to choose from. So we multiply by 3. Now, that person sat down. There's 2 seats left. There are 2 people left to seat. The second person has 2 seats left to choose from. We multiply by 2. Now there's 1 person left. That 1 person only got the 1 seat, got nowhere else to go, has to sit there. We multiply by 1. It doesn't change. So we do 4 times 3 times 2. We get to the conclusion that the answer must, of course, be 24. Unfortunately, 24 is not correct. And the reason it's not correct, because many students make a mistake, is because there are 2 ways to arrange Mr. Spencer and his 2 children. Imagine Mr. Spencer has named his kids A and B. Not very creative, I know, but bear with me. So let's say Mr. Spencer has kid A here and kid B here. This is one way to arrange it, but of course, the kids can also sit in the opposite order. Kid B can sit here, we can have Mr. Spencer in the middle, and kid A can sit here, which means that for every single one of these 24 arrangements, we can actually have 2 different arrangements, making the answer not 24, but in fact, 48. So here's an example of a tricky final step that we must miss. Now, some general tips about how can we try and avoid these sorts of errors when we miss the final step. A few things. Firstly, a common reason mistakes are made is because students assume that they've seen this question before, they think they know how to do it, and therefore they very quickly do the method that they're used to, and they miss the fact that the question is slightly different. This is very common. So especially like even students who've done many, many past papers, there's always a new type of question, right? You know, they write new questions every year. There's always going to be some sort of new variation on the question. So it's very important for students to not immediately go, oh, I've seen this before, I know how to do it, but to slow down and think, have I really seen this exact question before? Or is it slightly different from what's happened before? The second thing I would encourage people to do is write your working down. The more you do things in your head, the more you are likely to miss things. Because as smart as you may be, we can only hold so much information in our heads at one time, and we take shortcuts. The more mental arithmetic we do, the more shortcuts we do. Sometimes it's okay, but sometimes those shortcuts is very essential pieces of information. The third thing I would ask students to consider, and this is only if you have enough time, but to consider, can I do this problem in more than one way? Is there a second method to do this problem that's different from my original one? Because if you can get the same answer from 2 different methods, you can be relatively confident that you've got the correct answer. Not always, it's not a guarantee, but if you've got time, and perhaps not in the actual exam, but at least when you're doing it in practice and you're not bound by a strict time limit, test out a whole bunch of different strategies. And if you catch a mistake, then at the end of that day, you will understand much better why you made that mistake, and you will be able to recognize that in the future. So try a couple of different methods. The last thing I would ask people to consider, and this is more of an exam trick, is to look at the other answers. If you originally got 24, and you take a look at the other answers, you have 36, 48, 54, you might see that 48 is double 24, and that might ring alarm bells for you. Why did they put an answer here that's exactly double what I got? Is there some potential that I've missed something? Is there some potential that there is some way to double the amount of combinations I have? Don't stress yourself over. If you're 100% confident, okay, circle your answer and move on. But if you've rushed through it, if you're not 100% sure about this question, take a look at some of the other answers. Think, is there something that I'm not getting that might be revealed by looking at some of the other answers? Okay, so that's about missing the final step. So just to summarize, don't make assumptions. Don't just assume you've seen the question before. Make sure we write down our working. It really, really helps clarify our thinking and make sure we don't do those shortcuts that often result in problems. And finally, do your question twice. Look at some of the other answers. Think about, is there something I've missed? All right, so we'll clear that. We'll move on. Okay, so we're going to move on now to the next part of the talk, where we're going to address some common complaints that I get from students, some common areas of difficulty that they have. And we'll go through, again, some ways we can approach, or some ways we can try and overcome or learn how to deal with these difficulties as they arrive. And the way I'm going to do this is that I'm going to focus on 3 different areas of thought. I'm going to focus on spatial reasoning, verbal reasoning, and problem solving. And I'm going to give you some general advice on, if you struggle with these kinds of questions, how might we approach each? So spatial reasoning. What is spatial reasoning? Well, we discussed it in the question types a little bit earlier. It's all about having some sort of shape, having some sort of pattern that you need to try and manipulate. So here is the ever-present cube. I think many students will be very familiar with these nets and these cubes by now. You see them a lot. Effectively, every question is variation of, if we have a net, how can we fold it to generate a correct or an incorrect shape? And commonly I hear from students something like, I just can't do it. I just can't see it. Just doesn't make sense to me. And that's okay. Some people struggle with these sorts of spatial questions. Some people find it very easy. But if you're someone that struggles with it, there are a few things that you can try. Firstly, spatial skills are developed just like any other skill, and that's with practice and that's with exposure. So if you find it difficult to do it entirely in your head, what you can try and do is make a physical copy. So many of these questions basically ask you to rotate a net in your mind or rotate a cube in your mind. And if you're not used to doing that, it can be very hard to visualize. What you can do, of course, is just make a quick drawing of the net on a piece of paper, cut it out with some scissors, and fold the cube. So that way you can sort of try and test yourself. Okay, if I turn this cube this direction, what face should I see? Try and predict the answer, then you can actually turn the cube, see if you did it correctly. And even just playing with some of the different faces should get you used to effectively how these problems operate. So that's one thing you can try. Many students simply just haven't had any practice with doing these sorts of things in real life. So doing it physically first, and once we build up confidence, we can get rid of the aid and move to doing it in our heads. But it's very difficult if we don't have a lot of experience doing straight in our heads. The second thing we can do is, instead of trying to do everything at once, and a lot of students do try to do everything at once, they try to figure out what every side of the face should look like. That's not necessary. Rather, what we should be trying to do is identify some basic patterns that tell us the correct answer. So what we're going to do is, in this particular diagram, what we can see is we had something like these two triangles. This is very easy, right? It's a very unique pattern. We can see there are two triangles facing the same direction in a row. And we can look through the four nets and we can identify, oh, we can see this pattern here, right? The two arrows in a row. We see the pattern over here, these two arrows in a row. We look at nets 2 and 3, and we see that, can we see this pattern, these two arrows in a row, anywhere? Well, no, that doesn't look right. This doesn't look right either. None of these quite look correct, right? Same with problem 3. We don't see this pattern of 2 arrows in a row. So from that, we can realize 2 and 3 probably don't work. We don't see this very common pattern, this very easily identified pattern. And so already we can eliminate answers 2 and 3. So by looking at some very basic patterns, instead of having to imagine all 6 faces, you can just start with 2 faces. And it's much, much easier to do with 2 faces than with 6 faces. I can assure you of that. So those are some general tips that we can do. So spatial reasoning, just to recap, practice with them, print them out in real life if you have to. Just get used to doing these sorts of things, first with your hands, then with your brain. And secondly, don't make it harder for you than it has to be. If there are simple patterns you can see, use them. You don't need to solve everything. You don't need to balance or juggle 3 cubes in your minds. You just need to do the bare minimum that's given to you. Okay. We're going to move on, so just in the interest of time. Let's take a look at verbal reasoning. So verbal reasoning is sort of the critical thinking skills. We have an argument. What are some of the common problems I get? Again, sometimes students tell me, I just don't understand what the argument is trying to say. There's no easy solution to this, unfortunately. These arguments can be written in somewhat complicated English. That is true. Sometimes the words they use can be a little bit familiar. Sometimes it's just hard to get what it's trying to say. Sometimes the arguments are written in very elaborate or very advanced vocabulary. Part of this is just comprehension skills. And to get around it, we need to develop a better vocabulary. And the way I would advise doing it is wide reading. So these are meant to be similar to things you might see in the real world, things you might see on a blog, on a newspaper, on an article, or on an essay. So if we read and we understand these kinds of literature, we should theoretically improve our ability to comprehend. So I'll discuss this a little bit later, but one tip I have is, if you struggle just understanding it, read widely. So fiction, nonfiction, whatever you enjoy, whatever you like, but just make sure you do it and you read widely. Now, some of the other tips that we might have is try and go step by step. Don't try and look at the entire paragraph and go, okay, what is it trying to tell us? Go line by line and try and establish what is the purpose of each line. What is the first line? What does the first line tell us? So this problem 2, for example, is a bit of an argument telling us about what is virtual reality. It discussed the current limitations of virtual reality, what it can do, what it can't do. And finally, it concludes with telling us that it's not of any use to gamers or other clients. So to break down this article, this first line here, what it does is it gives us a bit of a definition. It gives us a context. It's not arguing for anything. It's not trying to prove a point. It's not trying to convince the audience. It's just giving us a little bit of information to help us understand what the author is trying to address. The next line is where the author really gets started with their point. The author tells us this technology is limited. It's got problems. You can only see it, but you may have controllers. So now we start to see a little bit more what the author is trying to say. And then this final line, we really see what the author is trying to do. So you see, however, at the moment, virtual reality isn't capable of offering a true realistic virtual experience. Here is the author's opinion. Here is what the author is really trying to say. So if we go line by line and we try and understand, what is the author doing? Why is the author even bothered writing this line? Right? Everyone's got things to do. Everyone has time that they want to spend doing something else. So why have they bothered even putting this in the argument in the first place? Break it down line by line. Try and get into the head of the author is something I often say. So try and get into the head of the author. Why have they done this? What else? The last thing, and this is sort of just an extension of what I just said, try and figuring out why the author has done a particular thing in a particular line, is to decide for yourself what you think the author's final purpose is. The author has spent an entire paragraph building up to something. And one critical skill, and something I often ask my students to define for me before we look at the answers, is what is the author's final conclusion? What are they really trying to say? Because if you can nail that, if you can tell me or tell yourself, this is what the author wants to say, everything becomes much easier. Because if you can know the true purpose, you can identify the endpoint, it's much easier to see this strengthens, this weakens, this is a flaw. Okay, so firstly, I would practice breaking down the different elements of an argument, and then I would practice trying to define, trying to argue what is the main idea, what is the author really trying to tell us. Okay, and another common complaint I get is that, there are 2 good answers. Whenever I hear that problem, I always ask my student, what is the author really trying to say? And if you nail down the specifics of that, you should be able to relatively easily tell which one of the 2 final answers is most relevant, because often they will both be relevant indeed, but only one of them will be directly connected to the author's true purpose. So that's a little bit on verbal reasoning. Okay, we're going to end with problem solving. This is sort of the last big category of learning difficulties I'd like to do. And again, you might have a common theme going on here. A common complaint we get is, how do I start? What is the problem even trying to tell me? And similarly to what I said about spatial reasoning, what I would say is, have a go. You don't need to get the answer on the first try, but just play around with what's happening. So take a look at what's being said here. We have this diagram shows the roads that connect 4 towns and the distances involved. Here's our diagram. It's a bit of a mess, but I think we can work through it. The author tells us, I live in Estover. This afternoon, I have to visit clients in Arthur, Chichester, Newton before returning to Estover. It does not matter in which order I visit the clients. Some students look at this diagram, they think, oh, it looks very messy. It looks like a spider web. What's going on? What's Arthur? What's Newton? What's Estover? Where do I start? There's no start point. No one's told me where to start. Where do I end? No one's told me where to end. How am I meant to solve this problem? Well, how we do it is we just play around. So what does the author tell us? We live in Estover. Okay, so we start here. We got to visit Arthur. We got to visit Chichester. We got to visit Newton. Doesn't matter which order. So how might I go there? Maybe I start with Newton. I go Arthur. I go Chichester. I go Estover. Maybe I go Chichester. I go Newton. I go Arthur. I go Estover. Maybe I go the other way around. Or maybe go Arthur, Chichester, then Newton, then Estover. Just have a play around with some of the different variations. And if you experiment a little bit, what it should help you do is understand what exactly it is the question is asking. Okay, now I get it. What I'm meant to do is I'm meant to calculate the fastest or the shortest route that visits all 3 towns. So you might be scared by this diagram. That's okay. Just start somewhere and see if you can figure out what it's trying to say. Again, just have a play around with these problems. The other thing I would say is, so trial and error is a really good learning process. Maybe it's not the best way to approach an exam, but at least when you're learning, when you're practicing, when you're learning, trial and error is great. It shows you, you can sort of teach yourself how to get through a problem just by playing around with some of the different things you might see. And if you do it enough, what it should do is teach you to adapt. No matter what the problem you get, you'll always be able to have a go, play around with it a little bit, and hopefully stumble across a solution that makes sense to you. Okay, so for problem solving, if you don't understand it, you don't get what's quite going on, just have a play around. Never let yourself get stuck. Never just sit there and look at a question going, panicking, going, I don't know, I don't know, I don't know. That's not going to be very helpful. Even if you don't know, have a play, start somewhere, go somewhere, try and figure out maybe even just a little bit of what's going on. Okay, what else can we do? So the second thing with these problems is that often it's difficult to tell if we know what the correct answer is. Because I might say that, you know, it looks like if we start at S Alfred, but then we go through U-turn here, that sort of looks like it might be correct, but how do I know it's correct? And what I would encourage students to do is try to not just guess at the answer, but see if they can't develop some sort of system or some sort of definitive approach to this problem. So in this particular one, what you would do is you would look at all the possibilities. How many different ways can I approach this? Well, I can take the long way to Arthur, the short way to teach Esther, and the long way to Esther. So I could take this little bend here, I can take this little bend here, or I can take this little bend here. And once you realize that those are the 3 different possibilities, then you can calculate the difference between the 3, and you can be quite sure what the final answer is, rather than sort of just giving it an eyeball or giving it an estimate and thinking, this is what I reckon the correct answer is. So having to play around the solutions, seeing what the different options are, once we've canvassed the total possibilities, we should be able to get a better idea of what the final answer should be. Okay, so we've talked a little bit about some of the common complaints of spatial, verbal, and problem solving. What I'd like to end up with just in the last 10 minutes is what can we do to improve going forward? So there's 2 parts to this section. Firstly, I'd like to talk about the approach I would encourage students to have while they're doing practice papers. And the second half would be what students can do outside of practice papers, because I hope students aren't doing practice papers 24/7. That's not a great way to learn. I don't think many students would enjoy that, but there are still things we can be doing both while we're practicing and while we're not practicing. So during practice papers, 2 things I would encourage students to do on, firstly, go past the answer, and secondly, follow up on your understanding. So this first one, go past just the answer. To students, and I'd like you to remember this, don't be satisfied with just getting the answer correct. The reason is 25% of all people will get the answer correct by just guessing, all right? So don't be satisfied with just getting the right answer, because 25% of people will do that by sheer luck. Rather, we should check our understanding, not just having the correct answer, but understanding the question as a whole. So some of the things we should ask ourselves, so if you got the correct answer, good job. First of all, good job, right? It's a great place to start, but we can go more than that. We can do things like check, what is this argument saying? What is the purpose of each sentence? Why are the other answers wrong? And if you really want to challenge, you can ask yourself, why did the author bother writing these answers? So we can apply this to other types of questions. Say you have like a spatial reasoning question. Let's go back to the cube question before. Let's say we've solved the answer. If you want to further test your understanding, now you can look at the other shapes. Okay, I've got the first 3 shapes. I know what this one looks like. Could I draw the other shapes? Let's say if it was net 4, could I draw the other 3 sides or the entire cube if it was 3, 4? So trying to further your understanding, making sure that you don't just know how to get to the correct answer, but you really understand what's happening in the question. So sorry, I might just jump back to the slide that we were on. So with these kinds of critical thinking questions, the 2 things, again, so as I mentioned before, that we should think about is what is the purpose of each sentence and why are the other answers wrong? So you've got the correct answer, great job. Now let's double check you really understand the problem. Ask yourself, what is the purpose of each sentence? So again, we did this a little bit before, but let's do it again with question 15. The author starts us off with a description. He tells us what they want to discuss. They want to discuss school uniforms. And what do they want to discuss about school uniforms? Here, the author leads out very quickly with their conclusion. They think that they're a relic of the past and that they're not appropriate in the modern day. Now we look at the next line. Instead of encouraging individual expression, uniforms enforce conformity and rigidity, which works against developing critical thinking and self-identity. Here we start to see some of the negatives. We have our evidence. The author tells us that what should school uniforms do? They should encourage expression, creativity, but they don't. What do? They tell us they encourage conformity, rigidity, a lack of creative thinking, and self-identity. So the first sentence, it gives us an introduction to the author's purpose. The second sentence, we have some evidence. The author is telling us some of the harms of school uniforms. So they've said school uniforms are bad. Now the second sentence, why are school uniforms bad? What do? What are some of the negative ramifications that follow from them? And then our final sentence, we have a bit of a conclusion. We hear what happens if we get rid of them. So what am I trying to say? Why are school uniforms bad? What are some of the benefits we get from school uniforms? So those are the three, that is why the author has written this paragraph in this way. You can understand, if you understand the purpose of each line, you should be able to very easily take a look at the answers and see which of them would strengthen or which of them would weaken. It's almost like you wrote the paragraph yourself, hopefully. Now, the other thing you can do is you can take a look at the answers and say, why did the author write answer A? Why is answer A confusing? What were they trying to trick us with answer A? Or what were they trying to trick us with answer B or C or D? So you've got the correct answer. You justify why you think the answer is correct. And now take a look at some of the answers. Why is this answer wrong? How might we make this answer correct? So again, as I said, have a play around with the question. Don't just stop at the correct answer to this is A, the correct answer to this is B. Have a look, say, what if we change this? What if the author tried to say something else? What would be the correct answer there? Or what if this line wasn't there? Would the answer still be this, or would it be something else? So don't just stop at getting the tick, getting the mark. We can go further than that. And this is a really great way to maximize your learning from any piece of paper. So from any practice paper. So instead of just saying, oh, I got 39 out of 40, good, move on, we can learn more from what we've done. The next thing is follow up on your understanding. So again, don't just stop at, I think I understand. If you have the opportunity to ask for questions, and the reason that Q&A is a really important part of the lessons I teach is because I think it's really important that students get the chance to double check they know what they got, and they will be able to do it again. So the key question that students should be asking themselves is, after they get something right, is, could I do this again? Or did I just get lucky? So if I got the question right, so if I got the question wrong, how do we follow up? Well, we ask ourselves, why did I get it wrong? How can I fix it? How can I make sure this won't happen again? So don't just say, oh, I got it wrong. Well, that's too bad. Well, we can do something about it, right? Ask yourself, why was it wrong? What mistake did I make? How can I fix this mistake? And how will I check that I have fixed this mistake? So go through that whole process. What if you got the question right? Well, if you got the question right, was my thinking correct? Was my reasonings correct? Or did I just get lucky with the answer? Those are the questions we should be asking ourselves. And then more than that, can I deal with variations on this answer, on this question? Do I only know the sort of very basic form, or can I do with something a little bit more advanced? The reason I put in question 6 as the example here, and having a quick read, there are 18 spiders, dragonflies, and cicadas together, but a total of 118 legs and 20 pairs of wings. How many dragonflies are there? This question is interesting because I think many students are familiar with a very basic form, which are, say, there are 20 people and dogs. There are so many heads and so many legs. In these types of questions, there are two variables. We have humans, we have dogs. We need to compare the number of heads and the number of legs. Relatively simple. A lot of students have seen it before. What happens when we add in a third creature? Not just humans or dogs anymore. Now we have spiders, dragonflies, and cicadas. If we added in this third variable, could students still do this question, or would they now be stuck? This is quite important. So making sure that we can, if you got the question right, sure, did I do this question correctly? If I saw a slightly different variation of this question, would I still be able to do it? And the answer is no, I would not be able to do it. Then we should be asking ourselves, what am I not understanding about this type of question? What can I learn to make sure that I'm prepared for any sort of variation on it? And the thing I often see for students who can do the basic form but can't do something a little bit more advanced is because they don't often understand the reason behind their method. Often, someone has taught them the correct method and they know how to write it down, they know how to repeat it, they don't understand why the method works. And if you don't understand why the method works, you're not going to be able to repeat it, or you're not going to be able to adapt it. So not enough just to go, oh, I've seen this problem before, I do this, I change these numbers, I subtract these two, and then I divide, and magically the answer comes up. That's not really understanding the problem. Understanding the problem comes from, okay, the reason I subtract these two numbers and then divide is because they represent certain things. When I subtract them, this represents something else. This solves the problem because. So not just knowing the method, but having an understanding of why the method works. So, so two things. If we got the question wrong, make sure we understand why we got it wrong, how we can improve, how we can check that we've improved. If we got the question right, was I lucky, or did I do the correct thinking? And if my method was correct, do I understand the method? Could I adapt this method to different kinds of questions? Or am I only have a very superficial understanding of what's going on? All right. The last thing I want to talk about is what happens outside of practice papers. We can't do practice papers forever. Practice papers only help us so much. There's a lot of things we should consider when we're not doing practice papers. Now, one thing I think is really important, not just for thinking skills, but just for your English comprehension in general, is to read widely. So make sure we're constantly challenging ourselves with reads, and make sure we're reading a whole diverse amount of information. A lot of students enjoy fiction, nothing wrong with that. Fiction is a lot of fun, you know, fantasy, whatever, but a lot of the critical thinking questions are not stories. They're things that you might find in newspapers, in blog articles, things like that. So the more exposure we get to these kinds of writing, the better we're able to handle seeing similar things in the end. So read widely, challenge yourself. This doesn't have to be a painful process. Hopefully, students should be able to find something they enjoy. If they have a hobby or something, you can take a look at, are there any blogs or any video essays on these articles, something that hopefully is of interest to a student that they want to go out and do and read, and developing our exposure that way. The second thing is not reading passively, but reading actively. It's all good to sit back and enjoy a story, or sit back and sort of just slowly digest the news, but being critical is good. So instead of just going like, oh, okay, the news headline is that happened today, Djokovic has had his visa refused. Okay, sure, moving on. We can do more than that, right? We can read actively. Why has the author started with this sentence? Why has the author arranged the paragraphs in this way? So instead of simply accepting what we've been told, going further, when we read, why has the author done this? Is this better? Is this worse? Does it make it more effective? What's the point? So instead of being like a passive learner, we can be an active learner in that sense. So in general, hopefully it's something we enjoy, but trying and seeking out things of our own. In terms of problem solving, something as simply as going out. There's some great TED riddle videos. I think a lot of students may have seen them coming up in their YouTube feed. YouTube recommendation algorithm is something else. If you've ever seen those TED logic puzzles, maybe the green-eyed people in the island, there's lots of different things we can do that sort of challenge ourselves, expose us to a variety of problems and a variety of texts. And it doesn't have to be painful. We can do it in hopefully a way that's engaging and interesting. That's it for today's presentation. So thank you all for coming tonight. Appreciate all of you attending. Now we're going to open to Q&A. What I'll do is I have a few questions that have been given to me in advance. I think a few parents and students have asked that I'll go through first, and then I'll open up to the room, and I'm happy to take any additional questions that we would like to address. So the first question I've been asked to talk about is, so a parent asks, what is the difficulty of thinking skills and how do children develop this ability? Well, in terms of the difficulty of thinking skills, it's difficult to say. There's no simple answer to how hard is thinking skills. The reason is because different questions are different difficulties, and different students will find different questions more or less difficult depending on what they're used to and the skills that they possess? So unfortunately, no simple answer to that. It really does depend on the individual student. In terms of developing though, how do children develop the ability to thinking skills? Again, there's no real dedicated training. It's all about picking up those critical thinking skills, breaking down an argument. And these skills we should try and develop in our everyday life. So when you read an article, being critical in its thought, when you see a problem, trying to understand the method in as much detail as possible. So of course, these practice papers are really good in teaching you, but more than that, we can do it everywhere else. So in your maths class, when your teacher tells you, oh, this is how you solve a problem, don't just copy it down in your book. Think about, okay, why did we start with this step? What does this step make sense? Am I just copying it down, or am I really thinking through why this leads to this, leads to this? So active learning. So that phrase is really key, active learning. The second question I got was how to improve the spatial questions. So the spatial reasoning questions, yes. So just to remind everyone, the spatial reasoning questions look at something like this. They often involve some sort of three-dimensional or two-dimensional pattern or three-dimensional object. And we need to recognize patterns, turn them in our head, figure out what exactly is going on. And I totally get it. Many students find this kind of problem really hard. I think we've talked about it in the past. So, practicing first with physical objects to help train our understanding, and then moving on to doing it in our minds. And also, as I said, don't make it more complicated than it has to be. If you recognize an easy pattern that will let you identify the answer really quickly, don't make it harder for yourself. It's really hard to balance 6, 7 different faces of a cube at once. I can empathize with that. These were tricky for me as well. But if you don't need to do 6, you can just do 3, take it. Okay. So how to improve spatial questions, practice, but also don't make it harder than it really needs to be. Think about how can I make this question simpler for myself? And one of those ways is identifying these easy patterns, the things like these 2 triangles in a row. Okay, the third question I get was what grade to start learning thinking skills? So this is an interesting question, and it's hard to say. What grade to start learning thinking skills or start practicing thinking skills together? I think probably the best answer is whenever you think appropriate to start practicing for the selective school test. I think doing practice papers in the kindergarten is probably not very helpful. But if you decide that you want to start preparing for the selective school test at this time, I would definitely encourage you to start doing thinking skills practice at a very similar time to whenever you start preparing. However, that's only in relevance to the practice tests themselves. We can always start learning thinking skills at any age, because it's not about preparing for a test. It's about developing the skill to break down an argument. It's about developing the skill to read an essay or read an opinion piece or read a headline, an article, and be able to figure out what is the author saying, why is the author written it in this way. These skills we can start learning at any age. It's more a matter of attitude to reading than it is something specifically that you need to go out and do. If you're constantly reading and challenging yourself to break down the argument, you will simply get better over time. And that's something we can do really at any age, as long as yes, because if you have basic logical reasoning skills, you can approach it that way. So when to do specific practice papers, I think that's an individual decision for whenever you think you want to start preparing for the selective schools test, but we can always start learning thinking skills elsewhere, not just for the test, but just in general. So I think that's probably, yeah, that's what I'd like to say for that question. Question number 4 was, what text traps do careless children need to pay particular attention to when they read the passages? So this is a good question. And I'm going to jump back to the bit here about misreading. There are, I think, 3 things I wanted to cover in terms of classic traps. The first trap is simply misunderstanding keywords. So highlighting things like strengthen or weaken, highlighting things like not, highlighting things like, so does this article not do this? So these are really, really basic mistakes that if you're careless, you can miss. So that's really the first thing. If you see keywords like strengthen, weaken, flaw, often they will be bolded for you. So the author here has been nice enough to even put in big bold text, strengthen. But if they don't do that, then you can do it yourself. So these are sort of the keywords we should be looking at. The second thing that is a classic trap for students are specific types of grammatical constructs that are a little bit tricky to understand. And to give you an example, it's something like, if A is true, then B is true. And often students who are reading very quickly miss the bit where it says, if A is true, and then they simply assume that B is true. Or in another example could be something like, the author says, it is silly, or it is presumptuous to say X. And when the author says it is presumptuous to say X, they mean that X is a silly idea. It has no logical merit. But if you miss that first grammatical construct, it is bogus, or it is erroneous, or it is presumptuous, then you're going to get the exact opposite meaning of what the author intended. So the more familiar we are with these sort of little turns, little phrases, or little turns of speech that can be used to drastically change the meaning of a sentence, the better we'll do. It's very hard to misread an entire sentence or entire paragraph, but it's very easy to misread 3-4 words that completely flip the meaning of a sentence on its head. So getting used to those little phrases can be very important. The third thing is not to make assumptions. Sometimes students don't know a word, so they just guess what they think the word is and move on. Sometimes it's okay, sometimes it's not. And when it's not, it can be really, really not okay. So if you don't understand a word, don't just guess. There are 2 things you can do. Firstly, if it's practice, look it up. There's always a good time to expand your vocabulary, and that time is now. So if you don't know what the word is, look it up if this is in practice. If it's not in practice and it's a proper paper, then look at the context. Just because you don't understand one word doesn't mean you don't understand the rest of the argument. And from the rest of the argument, you should hopefully be able to piece together what that word should be. So 3 classic traps that can be seen. Firstly, simply misreading keywords. Secondly, overlooking small grammatical phrases that completely change the meaning of a sentence. And thirdly, assuming you understand what something means when you really don't. So 3 things I think to be careful of there. First question I had was how to maximize thinking skills score in the remaining 2 months. So from this, I'm guessing that selected skills test is coming up very quickly for some of you. And I think the answer to this question is that it depends on what level the individual student is at. I think that if the student has already done past papers, they're getting pretty good results, they feel quite confident, then the answer is to, I think the most important thing at that stage is to get the student comfortable with the test. You have the information, you have the skills, you have the knowledge. What will really cost you marks is if you panic during the exam, or if you have a mind blank, or you simply don't perform well in the day. And the best way we can sort of approach that is just to be familiar, just to have practice, do a few papers, do them in an exam setting, and feel comfortable with the exam day. Now, don't exhaust yourself before the exam. If you go into the exam really tired because you've been doing papers till midnight the day before, you're not going to perform well either, but just enough so you feel confident on the day. If you don't feel confident 2 months going to selected school test, and maybe your marks, I haven't been so good, or you don't really understand the questions, it's very difficult to get enough experience, right? There's only so much time left. What I would encourage students to do instead is to try and develop a good approach to every question. So rather than trying to rely on intuition, so I can do this question because I've seen it before, that will be very hard to develop in a very short time frame. Instead, what I encourage you to do is, okay, maybe I haven't seen this question before, but let's have a good approach to every question. To say critical thinking question, one recommended approach I would have is, firstly, what is the author's purpose? Secondly, what is the author's evidence? So taking your time and to every question with an argument, doing the same thing. What is the purpose? What is the evidence? What is the context? And even if you haven't seen the question before, you can take your time, and with a rigorous approach, you should still be identifying the key pieces of information that have been given. So, if you are confident already, just be comfortable, get familiar. So on the day, you feel okay. If you are not that confident, I think the most important thing is, rather than trying to cram as much information as possible, it's developing a good approach to every question. That's much easier than trying to memorize an entire question bank of questions, because that's a very difficult thing to do. So yeah, so that's my recommendation for what we can do into the future. The next question I had was, thinking skills in the end is a test for children. What aspects of knowledge are tested, or how can we judge the so-called smart students in thinking skills? I thought this was quite interesting because, so basically the question was asking me, how can we tell which student is smart or good at thinking skills and which student isn't? Now, firstly, I don't think there is such a thing as a student who is universally good at all thinking skills, because there's a lot of different types of questions. But I'd like it to break it down into two categories. We'll look at the logical thinking first, and then we'll move on to the critical thinking. So if you remember that logical thinking is a problem-solving focus, then the students that I tend to see do really well on these types of problems, these logical thinking problems, are the students who can explain their reasoning. So I often ask my students to write down their working on the screen as we go through the paper. And they'll write down a few things, and the students who can tell me why they've done this as the next step, why they've applied this method, or why they've created this equation. So the students who are able to demonstrate that they can not only do the method to solve the problem, but they understand why that method solves the problem, are the students who do best. Because as we said with problem solving, it requires you to adapt. It's not just regurgitate the same thing you learned. It's about how can we apply the skills I have existing to new problem sets, to different problem sets. So I find the students who can explain themselves really well and say, this is why this method works, is those who do the best in these kinds of questions. So that's for the logical thinking. Critical thinking, I think, is also very similar. Remember, this is an argument-focused question set. The students that I find do really well on the critical thinking questions are those who can explain themselves very well. So students who are very well spoken, students who I ask, what is your reason for choosing A? Some students go, it sounded right. I thought it sounded correct. That's why I picked A. Some students are able to tell me in a lot of detail why they thought A was correct, why they think A fits in with the argument being made, and why they chose A over some of the other answers, and perhaps why they're able to discard some of the answers. So students who are able to explain their reasoning for choosing a particular answer over another tend to be those that I find perform very well, because again, it shows an understanding of the argument, not simply matching words or matching phrases and that sort of thing. So anything to take away, the so-called smart students, as the question asker mentioned, are those who truly understand what's going on and are able not just to understand it, but to explain it to me. It's often said, a phrase you may hear is that to teach is to show true understanding, and that is sort of true. If you can explain yourself to someone, it means you really know what's going on, right? So moving on to the next question, I was asked, what are the similarities and differences between thinking skills and general ability? Now, just as a word of warning, it's been a long time since I personally did a general ability paper. As you can imagine, it was a long, long time ago in my past, but I can still offer some general comments. As we can see here in the slide, GA, there's a little bit of GA still in the thinking skills paper, in that, so the spatial pattern recognition skills are still there. But if I had to make a comparison, I'd say that thinking skills is much, much broader. It still includes some general ability GA-like questions, but there's also a much more to it. So inside the logical thinking, there are some GA questions, but there's also these things like riddles, which I think are quite new. And then of course, there's a whole new set of questions, which are these critical thinking, argument-focused questions. And these are almost completely different from the GA questions we've had, in the past. So GA, they're still there. We still see some questions pop up from time to time, but it's now only a very small portion of a much bigger focus on a lot of much more different skills. So similarities, differences there. Okay, question number 8 was, what kind of question do you think needs the most attention and exercise? I hope to have some examples. So the most attention and exercise, again, is very difficult to say because, as I've stressed before, it depends on the individual student. Some students find verbal reasoning very easy. So perhaps these students are debaters, perhaps they love reading, perhaps they read a lot of news, they read a lot of articles, and they find verbal reasoning walk in a park. Never had a problem with it. But at the same time, they might find the spatial reasoning, moving cubes, turning cubes in the head really, really hard. Some students could be the opposite. They might be very creative. They might love working with their hands. They might find these spatial questions really easy, but they don't read the news. They don't like argument. They don't like logical reasoning, and they struggle with those. So the most difficult question and the one that needs the most attention is ultimately dependent on the individual student, but we can figure out what that is, right? So doing a few practice papers and seeing what students struggle with, and not just by the marks, right? The marks are one thing, but also the students' own thoughts. What was I uncertain about? What did I really struggle to do? What did I really battle to get correct? Those are the things that should clue you in to what needs the most attention and exercise. So again, very dependent, I think, on the individual. All right, that's all I had for the questions that were given to me. So what I'll do now is I'll open it up to the meeting as a whole. If there's any questions I haven't answered or anything you'd like to ask, feel free to put the questions into chat. I believe it should be open, and I'll do my best to get around to them. So I'll have to, sorry, one moment. Okay, so I believe I've opened chat to everyone. So again, if you could just keep it on topic, please. So only if you have a question you could type. I don't want to have to limit it to hosts, but if you have anything you'd like to ask me, feel free to put it in, and we'll take a look. Okay, so hello everyone. If you don't have, so hello, if you don't have anything to ask, please, I do get it, I say hi, but I do need to keep it into questions. Hello. Okay, Ethan, what about logic games? So Ethan, could you just confirm, as in, would you asking how to approach them, or what so? Beluga, any books you recommend to practice? Books is an interesting question. I don't have any particular books in mind, if that's your question. I'm not convinced about the value of books in teaching the skills. I think that the skills are best explained by an actual person, because books are very limited in focus. So in terms of books, I wouldn't recommend them for teaching the skills themselves. However, I do think books are really useful providing a whole variety of problems. If you just limit yourself to practice papers, you're only going to see the types of questions that are written by a particular author. Whereas if you get, so you'll see some books which like, I don't know, 101 riddles and puzzles or problems. Those are often quite good, because what you see is a whole range of different problems, and getting that exposure can be really, really useful. So that might be quite useful. If you want particular books, I'm afraid I'm not quite sure. Again, it's been quite some time since I personally sat the test, so I'm not sure what's in publication at the moment. How do you improve graph questions? So graph questions are interesting. I suppose they could be things like statistics, like box and whisker plots. So just to give everyone an indication of perhaps what this might mean, sometimes students see questions like this and they ask us to interpret the data. Now, graph questions, I think, shouldn't be too difficult as long as we understand how to read graphs. So what I would recommend is, and in this case, a textbook might actually be quite useful, just opening it up and understanding what every point on a graph means. So for students who've never seen a box and whisker plot, they can be quite confronting. You know, it's just a whole bunch of boxes and lines. What does each thing mean? But if you understand what the graph means, you should be able to read it. So for example, this is the lowest value. This is the highest value. This is the median. This is the first quartile, third quartile, etc. So with graph questions in general, if we understand the format, we understand how bar charts work, how pie charts work, how box and whisker plots work, then we should be able to pull out the information relatively easily. So as long as we understand the graph format, that's the first place I would start, I think. How often do you find GA questions in thinking skills? Hard to say, Brian. Perhaps in terms of the old style, maybe 1 in 5, 1 in 6, because obviously half the questions now are critical thinking, which are not GA at all. And of the GA skills remaining, perhaps they make up maybe a third or so of the remaining questions. So hard to be possible to say, but not that frequent anymore, for sure. So Dream, yes, books. I can't really make recommendations on books because I don't know any particular ones, but in terms of, as the more variety of problems you see, the better off you will be prepared. So any books that offer you something different, you know, just pick it up, take a browse. Have I seen these problems before? Or is there something that interests me? You can do those to do problems. In terms of reading widely, it doesn't have to be a book. It can be anything, but something you enjoy, right? Students who find something that they like or something that they're interested in are going to, do a lot better than something that's very dry and boring. I wouldn't recommend you read, for example, autobiographies or Seymour Herald unless you're someone that's actually interested in those sorts of things. Oscar, there is, perhaps I may come back to that in a moment if we have time. So Juju, for most efficient way for spatial reasoning questions. Yes, so again, with spatial reasoning, don't make it more difficult for you than it has to be. So again, to go back to the question here, where did I put it? This one. You could try and fold this entire net, but it is not necessary because, as we should realize, we don't even know what the other sides look like. We shouldn't have to worry about the entire net. It's much more difficult. The most efficient way is to find patterns that we can use to simplify the question. And in this case, we see these two triangles and we know, okay, now instead of looking at the entire net, I should just try and find these two triangles and we can start from there. And from there, we can build towards the final answer. So make it simple, find patterns that simplify the question would be my recommendation, Juju. So Angie, what games do you recommend to us that use logic and require thinking? Interesting question. So games, I'm not entirely sure. If you do enjoy logic puzzles and reasoning, I can advise you to look up a series of TED Talks that are just lots of different logic puzzles. Those are quite difficult, I will warn you in advance, but they're really good for getting into the sort of thinking that would encourage you to take towards problem solving. So if you're interested, if you just look up like TED Talks riddles or TED Talk logic puzzles, you should find them. That might be something. Take a look, see if you enjoy them. They're quite challenging, but I think quite good. Fiction or non-fiction? Both, really. So in terms of the critical thinking, non-fiction is probably more relevant. But in terms of developing vocabulary, developing comprehension skills, anything you read, as long as you're challenging yourself and pushing yourself, will still be useful. So I think having a balance of both is important, but the most important thing than anything is actually reading. So don't force yourself to digest 10 newspapers a day, because I don't think you're going to be able to keep that up. Find something you enjoy, try and strike a balance, but as long as you're doing it, that's something. Kevin, with the strength of the weekend or floor questions, when there are two clear possible answers, how do you tell which of the answer as both could possibly be true? Good question. Often authors design questions so there are two possible answers. And again, my recommendation here is make sure you're very clear with yourself. What do I think is the author's real purpose? What is the author really trying to say? So let me bring you back to this question. Where is it? Here on coastal ecosystems, Kevin. And what we'll realize is answers B and A are both good. This entire paragraph is on why coastal ecosystems need to be protected and why people need to do more to protect them. So the fact that they're really unique and they're really special is a good answer. But so is the fact that human pollution is speeding up erosion and speeding up destruction. How can we choose which of these two is the best answer? We have to go back to what is the author really saying. The author does talk about why coastal ecosystems are so beautiful and so important, but it builds up to the author's final conclusion. That's just the evidence. That's just the starting point. What the author is really trying to tell us is this final line here, that the public needs to do more. So if our final conclusion is that the author wants us to know or wants us to believe that the public needs to do more to save these beaches, the answer should be relatively clear. It should be A, because that addresses the author's true purpose. While B is relevant, and it does talk somewhat, it's not the most aligned to the author's true purpose. So the better we understand the argument, the easier it will be to figure out which of the answers is best from those remaining. Ben, what paper should I do? Again, I wouldn't be too stressed about finding the best papers or the most appropriate papers. A variety of problems and a diversity of problems is what will teach you the best in the end, I think. How many math skills are in thinking skills now? In terms of math, there's a lot of it. That is true. There is a lot of math and thinking skills, but none of it is too difficult. So don't worry about doing year 8, year 9 maths in advance. You won't need it, right? As long as you have some year 6, year 7 level math skills, it will be enough. The key thing to know is not very tricky math concept. You don't need to imaginary numbers or parabolas to do the selected skills paper. What you do need to know is how to apply math skills to each individual problem. So rather than focusing on learning really advanced math concepts, just learn about mastering the basics and figuring out how can we apply these together to solve a problem. Alice, what happens if you're doing a paper and you're reading a question and you don't understand most of the sentence? So there's no easy answer to that, unfortunately, in that if you don't understand it, we need to try and figure out why you don't understand it. Is there a vocabulary problem? So if you don't understand the meaning of some words, well, first step would be to look up those words. So just Google what those words mean. Once you understand what those words mean and you still can't pass the meaning, well, if it's a single sentence, probably the issue is that you haven't read widely enough, in that you haven't seen enough questions, you haven't seen enough articles written in this style. So it's very difficult for you to sort of piece together the meaning. So unfortunately, this is one of those questions with no easy answer, but reading widely, if it's a comprehension issue and you just don't understand what it means, firstly, make sure you understand each individual word. Once you know that, then we might need to start looking at how does this fit into a sentence, or how does this fit into a paragraph, which we can achieve just by reading widely, I think. So unfortunately, it's not an easy question to answer, Alice, but it's the best one I've got. Nikki, I think these slides, I think, should be available afterwards, although I can scroll through if you would like. There should be, although I will throw as we go. So Forrest, yes, recommending reading anything that should just strike a balance, strike a diversity, anything that interests the particular student would be good. Again, variety, I think, is key. How do you remember the definitions of words more easily? That's a good question. So definitions out of a dictionary are hard to remember and also not very useful. All right. I wouldn't memorize definitions out of a dictionary. A dictionary is just a starting point. The best way to remember the definition of a word is to see that word used over and over again. If you can see 100 different ways a word is used in the sentence, you will much more easily realize how that word is used. That's the practical knowledge. Memorizing the dictionary definition doesn't really help you understand how it fits into a sentence. What will help you understand how it fits into the sentence is seeing it in a lot of different sentences. So that's probably the advice I have there. Melody, you don't know the answer, how would you guess? Well, I would never encourage students to guess blindly. So, the flip a coin, or, circle in the air, pick A, B, C, D is not a good practice. I would at least have an attempt and take a look at what's reasonable. So it would depend on the particular question, Melody. It's hard to say in general terms, but see if you can't at least attempt it and make an educated guess is the phrase I would use, an educated guess. The answer is number 11. I'm not sure which one is. Sorry. My apologies. If it is this one, then yes, I can. So I believe this one was, where was it? This one was answer C, 86 kilometers. Harry Potter. Harry Potter is not a bad fiction book. If a student struggles with just like comprehension, then Harry Potter is not a bad series, and it's one they might enjoy. When handling time pressure, I would often advise practice, but it's also important to identify where the time is being wasted. So in practice, it should be approximately 1 minute a question, right? That should be the aim. So if you're timing yourself and you're trying to figure out where is the time being wasted, and from there we can try and work through where we can try and improve. Handling time pressure, be consistent. Don't let yourself spend 20 minutes on one question. That's never a good thing, right? In the end, it's only one mark. So if you are really stuck, move on. So games of high school logic, I think I answered that one. Books and media, yes. 2 questions are similar. Riddles. Nigel, how do you tell a flaw from a weakening question? This is quite interesting. So the difference between a weakened question and a flaw question is a flaw question asks you to find the problem in the existing reasoning. So ask yourself, what is the author's purpose? What is the author's evidence? A flaw will ask you to find the problem, why the evidence doesn't lead to the conclusion. This is different from a weakened question, because a weakened question doesn't need you to disprove the argument being made. It just needs you to weaken the conclusion. So it could be a completely different attack. It could be sort of an unrelated piece of evidence that still weakens the conclusion. That would still weaken it. But a flaw very specifically asks you to identify the problem in the argument given. So that's, I think, the difference between those 2 questions. Yes, absolutely. You can use the dictionary even. If you don't understand a word, look it up. That's it's very simple advice there. If you don't know it, look it up. Cambridge thinking skills class questions. Luke, I'm not familiar with those, so I'm afraid I can't give you a proper answer with that. Alex, thinking skills test. Sorry, we might do one or two more questions. I do believe we might be running out of time quickly. Just for those who are giving me book suggestions, any fiction book is fine. Just read widely. So fiction, non-fiction, anything you enjoy is okay. Something you enjoy is much better than something that you won't finish. So pick something you like, but also stretch yourself. So, you know, if you haven't done something before, take a look, see if you might enjoy something a little bit different. Sorry. Reading newspapers, not everyone likes newspapers, but at least give it a go. So even just like a very quick, just a front page or just a headline or one important article a day. Or if you don't want to read newspapers, you have like a hobby, you can read a blog. So maybe look up some articles on a topic that you're interested in. It's not so much about the source, it's about the type of writing, that analytical, that critical thinking writing is what I would recommend. If you don't know, Christine, a word and passage, it is okay to guess, but when you say guess, don't just make a random guess. Try and infer from the rest of the passage what would make sense. So what would make sense for this word to mean, given everything else that I have already read? That is the best way to approach, because rarely does the author use something that doesn't make sense compared to everything else. For any specific website or resources, I'm afraid I don't know. I probably haven't seen them. There's a lot out there, so I'm afraid I can't answer that. Do I recommend marking the keyword? Yes, I do. So if you have keywords, so Anna, if you have any keywords that you think are important, I would recommend writing them down. Okay, so I might take one last question. Sorry, I just need to find something. Okay, the last question to answer is on making an educated guess. So obviously, we don't want to be in the position to make educated guesses, but it's inevitable. Sometimes we do have to make an educated guess. Effectively, it depends on every question. But what I can say is be strict on yourself. If you put down an answer, make yourself give an explanation. If your explanation shouldn't be, it feels correctly, or it feels right, or it feels approximately correct. Think about, and if you have to make an educated guess, you can start from the answers. You can take a look, A, B, C, D. Why would one of these make more sense than the other, even if I'm not 100% sure? But you know, it's very tricky, educated guess. It's very difficult to give generalizations, but effectively be strict on yourself. Make sure that you at least try to justify